email to this, properties.
Oh,
I forgot to include them. So it started with properties of alcohols, went on to the reactions and synthesis of alcohols, ethers, and epoxides. Went all the way through acid derivatives, not mechanism. Okay. And I'll send out an email. I gave you 4 mechanisms that could be on the exam, and I forgot one, which is the synthesis of imines. So we can have hemiacetals to acetals, acetals back to hemiacetals, an aldehyde ketone plus an alcohol to a hemiacetal and backwards, and then aldehyde ketone plus amine going to imine. So those are all 5 of the mechanisms that could be on the exam. Okay, but not mechanisms of the acid derivatives. Okay, what would you like to go over here? Yeah, David?
The mechanism of the amine.
Of the imine. You want to see one of those. Okay. I think there was one on one of the practice sheets, but I'll make one up. So that's one thing that you want to talk about. What else? Cynthia?
I just have a question. I forgot, did you say last class that there is going to be an electron pushing example or demonstration? So just for those ones?
These are electron pushing mechanisms.
Okay, not synthesis. So those are electron pushing. Okay, got it.
I'm sorry?
Is that going to be, are those going to be synthesis reactions?
These are all mechanisms.
Oh, just mechanisms. Okay.
So these are the mechanisms for our unit. So that's all the electron pushing. Being able to go from hemiacetals to acetals, acetals to hemiacetals. Synthesis, wide open. Everything through acid derivatives. Old stuff too, unfortunately. You're likely to have a synthesis, a mechanism, a bunch of provide the product problems, some sort of an explanation problem, maybe. You know, what's a good topic for explanation?
Properties.
Properties of alcohols would be a great topic for an explanation. How about something else that I could ask about for explanation? Did in class. For the quick question.
Properties of acids?
Acid derivatives. So the acid derivatives, we talked about their relative reactivity and an explanation along those lines. So those are 2 areas where I might have provide an explanation type problem. Okay, what else do you want to make sure I go over? We've got a mechanism of imine formation. What else do you want to talk about? Yeah.
Separation of mixtures with acid base.
Okay, now if I gave you that one, it would just be a pair of molecules. Okay, so we'll do an example like that of separation. So that's separation based upon acid-base. Okay. What else? Michael? Yeah, I can get creative, sure. What else do you want to make sure we talk about? Probably a short review session if that's all you want to talk about. Cool. Anthony.
Can you also talk about like the reactivity of acid derivatives?
Yeah. Okay. else? Yeah.
Do you want us to know the cyclic hemiacetal and acetal mechanisms?
That would fit in here, yes. So these would include cyclic or non-cyclic, either way. So do you want an example of something like that? Of a cyclic example? Okay. Mechanism.
That's our deal solvent.
Sure. Yeah.
Protection of alcohols.
Don't really need it.
No?
So protection of alcohols, all we need to know is that acetals are good for that. That's all we need to know. That would be a more advanced course where we'd have to do something with protection. So I'd say I wouldn't worry about that aspect of it. We saw it back in arenes, that we had to protect an amino group in an example. It's a more complicated concept. Anything else? Well, we can add to the list if you'd like as we go along. How about we start with some mechanism? Okay, so I'd have to provide the starting material and the product, and then I'd ask you provide a mechanism for this reaction, including all electron pushing and the structure of reaction intermediates. Can you put some labels up here that might be helpful?
Acetal.
Acetal. How do you know it's an acetal? It's good.
You have an OCO.
Good. Carbon with an OC, and that carbon has an OC. So that makes this an acetal. What's the product? This is a hemiacetal. So it may look like a complicated structure, but this is the hydrolysis of an acetal to a hemiacetal. That's all it is. So you can get beyond the shrubbery of what the molecule looks like and kind of try to put a label on starting material and product. Okay? So I'd encourage you on a problem like this, draw in all your lone pairs, draw out the structure of H3O+, so you can actually do some electron pushing with it. So we can put lone pairs here, here. Here's H3O+. All right, tell me what you do first in the mechanism. Can't do it. You were here this morning. You can't say anything. You can't say anything, Anthony. We did this morning, all right? Make everybody else work at it.
Pull one of the hydrogens off of the H3O.
And do what with it?
We'll put it on that oxygen on the right.
Okay, I like that. So we've got oxygen, lone pair, hydrogen, break the oxygen, hydrogen, like that. Yeah, good. But I don't understand, why can't I just break a carbon-oxygen bond here? I mean, that seems unnecessary, you know, the Occam's razor says simplest is probably the most easy. Why can't I just do that for starters? Can't say anything, but
Carbon doesn't have, we don't have, well, I guess it could.
we're gonna have carbocations along either mechanism we come up with, but why might that not be a good thing to do here?
Looking at your hemiacetal, you see that you kind of need that oxygen and hydrogen. So you kind of, if you take it off, then you have to put it back on eventually.
Oh, I bet I can figure it out. Watch, I'll make this positive charge. Like that, I'm happy.
Because the alkoxide is a strong base.
I still don't understand why. What's wrong with that?
So with the leaving group.
There you go. Just bring it to Melinda there.
Yeah,
She told you. Yeah, this is going to be a bad leaving group.